So, because trig ratios involve relating angles and sides of a triangle, we can use trig ratios to not only find sides, but also to solve for angles in this picture, okay? So there's an example right here drawn for us, all right? So example 3 asks us to find the measure of the indicated angle round to the nearest degree, okay? So letter A says, what is the measure of angle A? So if you look here at the current problem that we've got, we look at this and see, like, okay, we've got angle A, angle B, we don't know those. We know AC is a 36-inch length, and BC is a length of 19 inches. All right, and we're asked to find the measure of angle A. And right now, without kind of using what we're going to be learning today, we're kind of stuck, right? We wouldn't be able to find angle A unless we maybe knew what angle B was, or something like that. We don't have enough information here to really solve, okay? We can kind of like use a little bit of understanding. For example, we know that angle B, how will it relate to angle A? Is angle B going to be bigger than angle A, or is angle B going to be smaller than angle A? What do we want to say here? Will angle B be greater than angle A, or will angle B be less than angle A? Or can we tell? I guess I'm kind of asking the question, so I guess we can tell. Which one's going to be bigger here, angle B or angle A? Hunter?
Angle B is going to be bigger.
How do you know?
Because the 36 is 19.
Angle B is opposite the 36-inch side, and so it's going to be bigger than angle A, which is opposite the 19-inch side. That's right. And of course, you know the biggest side, Hunter, is going to be which side here? Well, the side opposite angle C. So yeah, AB will be the biggest side. That's right. Okay. So again, it's like, all right, how are we going to find angle A? So our question is basically, it's like we want to find this angle here, and I'll call it like X maybe. Okay, they just use A. But if we look, okay, it says step 1, write the tangent ratio for angle A using the known values. Now, why did they use tangent here? Why did we use tangent? Why not sine or cosine? Evan?
Because the opposite side is the side that you can determine the triangle, and it shows the adjacent side.
Right, the two pieces of information, the two sides that we were given here, the two sides we're given is the opposite leg and the adjacent leg, and so to this angle A, and so tangent's the only one we could use. If we were trying to use sine or cosine, they would both involve using the hypotenuse, which we don't know. Now, could we, if we really wanted to, like if Evan was just like, I gotta use sine, that's all I ever want to use, could Evan use sine here? Could we still do this problem using, could we get this, I mean, could we use sine here eventually? What would we have to do if I wanted to use sine here? Like sine of x. What would I need to do? Find the hypotenuse. And how could we find the hypotenuse? With the information we've got, how could we find the hypotenuse? No? Okay, and I want to help Evan out. How can we find the hypotenuse? Yeah, Stephanie. Yeah, we could use 36 squared plus 19 squared equals that hypotenuse squared, and then just use Pythagorean theorem there, Evan. That's all we got to do, right? So that was it. And then we could use sine or cosine or tangent. And if you have all three sides, you can kind of pick whichever one you want to use. But since we only have the opposite leg and adjacent leg in relation to that angle, we're going to use tangent. And so we set it up just like you see there. Tangent of A equals 19 over 36. So I'm going to write it up here just because I like being redundant, I guess. All right, so tangent of X, because I call that angle X. Sometimes another variable that you'll see used is this symbol right here. It's like an oval with a little line drawn through it. Okay, that is a Greek letter from the Greek alphabet. Okay, in fact, if you go to Greece today, you will see this letter in use. Okay, and it's called theta, Theta. Okay, that's the Greek letter theta, and that's like the traditional variable you use when you're talking about an angle, theta. Okay. So you might also see it written then as tangent of the Greek letter theta. All right. And so let's see here. So we know tangent is opposite, right? According to SOHCAHTOA, tangent is opposite leg, so 19, over adjacent leg. Okay, so that's the same thing there if I was doing the tangent of theta, right? Now, if I want to know what angle A is, that means I want to get this x here by itself. I want to like cancel out the tangent and just have x by itself. So some students, okay, when they look at this, they think, Mr. Witt, all you need to do here is divide both sides by tangent. This is tangent x, and so that means if we just divide both sides by tangent, then we would get our answer. And so they write something like this. I see sometimes students write something like this: 19 over 36 divided by tangent. Okay? But that's not right. Okay? You don't take, this is not tangent times x, it's tangent of x. And so we need to cancel it out, not by division, because it's not tangent times x. We have to cancel it another way. And the way we do that is using something called the inverse tangent. Okay? So we use tangent inverse for the same reason why we use like multiplication when we want to cancel out division, or we use addition when we want to cancel out subtraction. Okay, those are inverse operations. Well, the inverse to tangent is this tangent with a little -1 symbol like that. And so tangent of x is equal to 19 over 36. That's the same thing as saying x equals the tangent inverse of 19 over 36. Like so. Oh, you can't see it, sorry. Okay. And then this, how do we evaluate that? We use our calculators. Okay. So to access tangent inverse like that, well, you can see there's the tangent button. Oh, no, you can't see it because it's off the screen. Let's see if I can like adjust this here so I like fit everything. Yes, bless you. If you look at tangent, right above tangent in blue for my calculator, some of your calculators will be in yellow, you'll see that tangent -1. That's tangent inverse. And so we're going to press second tangent. All right, we get that tangent inverse command, and then we'll do 19 divided by 36, close parentheses, hit enter. And there we get 27.82409638. Okay, which they said to round to the nearest degree, so that means we would round that to 28 degrees. So x equals 28 degrees. Okay? So that's how we do that. Yes?
You can do it in your phone, but like it gave me a different answer.
Make sure you're set to degree mode and not radian mode. It was?
It's on degree.
It does on degree, and it gave you a different answer. What's the answer that it gave?
88.
Hang on. Interesting. All right, I'll have to take a look at that because it should be 28. So yeah, it's not going to work. Yeah, no, I'm not sure. All right, I'll come take a look at that and see. All right. So now let's look at the next one. Now it says the next question is, what is the measure of angle B? All right, and so let's try and set this up here. So now we use the tangent of B. So tangent of B, and let's go to, I'm going to call someone here. So for the setup, Drew, tangent of B, what's that going to be? What over what? 36 over 19. Yep. Okay. And so we want to write the inverse tangent equation. So that'll be tangent inverse of, whoops, I'm writing this like way crazy. Tangent inverse of 36 over 19 is equal to the measure of angle B. Okay. And then let's see here, when we actually type that into our calculators. Okay. Stephanie, did you get to type that in your calculator there?
Yeah.
What'd you get? 62. Okay, well, yeah, and so it's like 62.1759032, which again we'll just say is 62. We'll round that down. Okay. Did we need to go through all that work to find measure of angle B, though? What could we have done instead?
Subtracted 90.
Yeah, so I mean we've got, if this is 28 degrees right here, okay, if that's 28 degrees, then to find the missing third angle in a triangle is we subtract from 180. 180 minus 28 minus 90, and that would give us the 62 degrees. Okay. Now, obviously, if we made a mistake in the 28, we're going to then have a mistake here in the angle B as well, so that's why you got to be careful, but that's the idea. Okay. Questions on any of that? All right, so go ahead and take like a minute and find, for number 8, go ahead and find the measure of angle J. Go ahead and find the measure of angle J in that. And feel free to round it to the nearest degree.
I got it.
Oh, okay, good. Yeah. Is it like not? It's giving you grades. Okay. Thank you.
Option.
Wait, is that, no, wait, no. Here we go. Angle, there we go. So, okay, so let me go back to where we were. Alright, so home screen, right? Shift menu, go to setup. And you go down here, see where it says angle, you see it's rad, that's what for ratings. When you want degrees, you press F1. And now it should stay that way, so we go back. Now, it looks like, what was it, like a tangent of, what were you trying to calculate? 4793? Voila. Okay, let's go to Shannon. What'd you come up with there? Your calculator needs to be fixed too, I bet. You got some like funky decimal, I'm guessing, right? Or like it didn't. Yeah, it's okay. We'll come back. I'll be able to fix yours, no problem. Julie, what'd you get?
26 degrees.
26 degrees. Sounds good to me. Tangent of J is 46 over 93. So J is equal to tangent inverse of 46 over 93. So J is 26 degrees. That's right. Okay. Very good. Questions on any of that? The setup there? So now this is how we can use these trig ratios to solve for angles. So now we see how to use the trig ratios to solve for angles and for sides. Okay. All right, so we're just going to skip through this. Move on to the sine and cosine. So on page 701, at the very bottom there, okay, look at that, 701. Okay. And so it's basically the same thing, but with sine and cosine. Again, I'm not really sure why the book decided to split up the two, but they did. Okay, so we're just going to do it the same idea. So, let's look at this triangle right here, and it doesn't really say. Okay, so let's just solve for angle A here, for example. So let's just call that, I'm going to use theta here just to change it up a little bit, the Greek letter theta. Theta. All right. And so based on that setup, based on where my theta is and the information we're given, all right, Lindsay, what is 5 in relation to that angle theta there? Is that opposite leg, adjacent leg? It's opposite. That's right. And then what's the 10? Yeah, good. I mean, so technically it is adjacent, right? We've got to be careful that we want adjacent leg, but you were right. You corrected yourself. It's a hypotenuse. So that means which trig ratio, if we're going to find angle A here, given this information, what trig ratio do we want to use? So tangent, remember that's the SOHCAHTOA part, that's opposite leg over adjacent leg. And we just said that was the hypotenuse, right? I mean, it's adjacent, but not the adjacent leg. That's the hypotenuse. So which trig ratio has opposite leg and hypotenuse in it? So cosine is ka, that's adjacent leg over hypotenuse. So then by process of elimination, it's got to be sine. It's going to be sine here. So let me spell that out here because I know SOHCAHTOA is not. There we go. So that's sine is opposite leg over hypotenuse. So we have the opposite leg right there over the hypotenuse 10. And so we'll say sine of theta equals 5 over 10. Now, actually, we could actually figure out this angle theta here before knowing how to do this inverse trig stuff. If you look here, it looks like the shortest leg of our triangle is 5, and then the hypotenuse is twice that, 10. Where have we seen that relationship show up before? Where the shortest side was some number, and then the hypotenuse was twice that number. Yeah, up on the board. It's a 30, 60, 90 triangle. Oh my gosh. So that means that what is this angle theta probably going to be? 30 degrees. Well, let's find out if it is. So that means we have to do sine inverse of 5 over 10. So second sine, 5 over 10. What? It's exactly 30 degrees. How about that? It's pretty neat. Okay. Okay, so 30 degrees is that angle. By the way, what would the length of AB have to be here? Yeah, what was it? 5 times the square root of 3, because that's what that side is. X is 5, right? And this is 5 times the square root of 3, so it's just 5 squared root of 3. You got it. Okay, very good. All right, let's try another one here. So this one is not that same relationship, right? So we have like what looks like the shortest side and the hypotenuse. It's not exactly double, so it's probably not going to be that same relationship here. But let's set this up. So I'm going to go to Adam. All right, so Adam, pick an angle you want to solve for here. You want to solve for R or for P? Angle R. Sounds great. So we'll call that, I don't know, I'll call that one theta. All right, so given the information that we have here, which trig ratio should we use here, Adam? So okay, so yeah, no, that's right. Just sine. So sine of theta, and what would that equal? What over what?
7 over 13.
You got it. Opposite leg, 7 over the hypotenuse, 13. Okay. And then when we want to figure out what theta is, we want to figure out that missing angle. So we'll do sine inverse of 7 over 13. Which, what do you get when you type that in there, Adam? 32.57. So then, if we were rounding to the nearest degree, because that's what the directions say, to the nearest degree. So 32.57, we'd round that to what?
33.
Yeah, I'd say 33. You got it. Okay, so this is 33 degrees. Okay. And then let's see here. Keegan, how about for P? So let's say we're not going to like do the we could do 180 minus 90 minus the 33 to get angle P. But let's set this up using a trig ratio to just get that practice in. So if we want to solve for P, I'll call that one like X instead of theta. So what trig ratio we want to use here?
It's going to be 13 over 7 out of that.
So we're going to use these two sides, and 7, it's no longer opposite. So if here's angle X, okay?
So it won't be that.
This is the adjacent side, right? This is next to adjacent leg, and then this is the what of the triangle? It's opposite the right angle, so it's the...
Adjacent? No.
Well, it is adjacent to the x, but it's not the adjacent leg. So when we use the word adjacent in our trig ratios, it's always adjacent leg. 7 is a leg. It's touching that right angle. But the 13, what do we call that? Hypotenuse, okay? So which trig ratio uses both adjacent leg and hypotenuse in it? I'll write it out here. So toa.
Cos.
Yeah, cosine does, exactly right. So I'll write cosine of x equals adjacent over hypotenuse. Okay, and so that means x is equal to then cosine inverse of 7 over 13. Yeah, you want to type that in there for me. What'd you get?
57.4. 57.42.
57.4, so we'll round that down to 57 then?
Yep.
Okay. Sounds good. So there's x, 57 degrees. Okay, which is angle P, I guess, really. All right. All right, go ahead, take 2 minutes, 1 minute. Maybe you've already done it. 13 and 14 there from the your turn. All right, give that one a shot. So I'll do it too here real quick. Let's see.
Is that right?
Yep. Mm-hmm. Mm-hmm. All right, the nearest degrees. You write the nearest Good job. Wrote that. Right. I think you didn't switch up. Or it's like, yeah. Oh, no, that's right, actually, never mind, that would be right. But I think it's maybe where you have the degrees, and you can use, like, the setup is actually right for both of those. Maybe make sure we cosine inverse and sine inverse too. Yeah, that's.
Yeah, and it's,
Okay, there you go. Because the setups were right. So, yeah. Okay, so let's do it. Okay, let's do it. Let's do it. Let's do it. Okay, yeah, that one's good. Yeah, that looks good. Yeah, there you go. So, all right, so we should have gotten here 53 and 37. Now, if you look at the rounding here, for example, for like that angle Z, when I set this one up, I got 14 over 23, I got 37.495, so like, when I round that, like depending on how I choose to round that, right, like the 9, that technically rounds up. The 4 then would become a 5, and then 5 we know normally rounds up. That would give us a 38 degrees. But then here I rounded this one up to 53, and so some people I saw wrote 53 and 38 degrees. And I'm like, you know, depending on how you round, I could see that. But then the problem is, right, if we say 38 degrees for this angle and 53 degrees for that angle, what's going to be the problem? What will be the problem there? Well, right, then we're no longer, our triangle will have angles that are more than 180 degrees when you add them up. So, something you want to look out for. I don't think I would take points off for it just because, you know, it's like I can see what you're doing there. But also understand, we still want our triangle to add to 180 degrees there. So, you know, maybe use that to help you guide your rounding too. Even though I know technically, yes, the 9 should round up and that should round up then. Still. Okay. That's the idea. Any questions on any of that? All right, so that's it. That is it. So I'm going to have you guys get started on your assignment.